Okay, Wildcats. Today we're looking at Wednesday, February 27th, graphing rational functions on page 57. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, graphing rational functions on page 57. Graphing rational function steps. Step 1, factor the expression. Step 2, identify the holes. Step 3, find the vertical asymptotes by setting the denominator equal to 0 and solving for x. Step 4, find the horizontal asymptotes or the slant asymptote by using the long division. Step 5, find the x-intercept zeros by setting the number equal to 0 and solving for x. Step 6, graph the above information. Step 7, graph the critical points. If you would, update your notes. All right, now your notes are updated. Let's take a look at our examples. Now I've added some lines to kind of help keep the work organized. You can do that if you don't have to. All right, so the first thing we do is we need to factor the numerator. Okay, so parentheses, divided by x. There's nothing to factor with that. We know x and x makes x squared. I'm going to put a 1 in front of there. All right, now to factor, we need to find all the combinations to make -6 and combine to be 1. So 1 times -6 is -6. 1 minus 6 is -5. That doesn't work. 2 times -3 is -6. 2 minus 3 is -1. That doesn't work. 3 times -2 equals -6. 3 minus 2 equals 1. This works, so our factors are 3 and -2. All right, so x plus 3x minus 2. Okay, now because nothing divides and becomes 1, there's no holes. Okay, so now step 3, find the vertical asymptote. Now to find the vertical asymptote, we set the denominator equal to 0. Now I'm going to do the vertical asymptote in yellow. So vertical asymptote is at x equals 0. Now asymptotes are dashed lines. Okay, now next step is to find the horizontal asymptote or slant asymptote. So to do that, we divide x into x squared plus 1x minus 6. Make sure we don't steal space from the critical points. All right, so the first thing you ask yourself is, what do you multiply x by to give you x squared? The answer to that is 1x. As soon as you get an x in the quotient, we know it's a slant asymptote. Now, x times x is x squared. X times x is 1x. We subtract. Cancels, you get 0. Oh, wait, I'm sorry. That's wrong. I put a second term there, but there's only one term to get that, so that's 0. So then you bring down 1x. Now, what do you multiply x by to give you 1x? The answer to that is plus 1. The quotient is finished, so you have a slant asymptote at y equals 1x plus 1. And I'm going to, for 1, I'm going to divide that by 1, so we have our slope, and I'm going to graph our slant asymptote in blue. Okay, so here our y-intercept is 1, so we put it 1, and then our slope is rise over 1, 1 over 1, so we go up 1 to the right 1, 1 to the right 1, up 1 to the right 1, so on. And then you can go the corresponding down one to the left one. Okay. Now, slant asymptotes are dashed line. Okay. Now, the next step is to find the X intercept. So, or zeros, we call X intercept 0. So to find that, you set the numerator equal to 0. So I'm actually going to use space from here to find that. So X plus 3 equal to 0. And X minus 2 equal to 0. So X equals -3 and X equals 2. So our zeros are -3 comma 0 and 2 comma 0. And I'm just going to write those in pencil. So -3 0 and 2 0. Now, when we mean by critical points, are points that allow us to know where the curve are. In this case, we lucked out because our zeros are critical points because they tell us that the curve is here, and this point tells us the curve is there. So our critical points in this case are -3 0 and 2 0 because they tell us that this curve is here and this curve is here. All right, so if you would finish up example 1. All right, now let's take a look at example 2. So first step is factor expression. So here it looks like we can factor 2 out. And I'm actually going to do that here. That's 2x squared minus 1. And the reason I'm going to do it here is because I recognize that once I do that, that's a difference of squares. So x squared minus 1 factors to be x plus 1 times x minus 1. Now here, this is again difference of squares as well. So that's x plus 2, x minus 2. And I apologize, I accidentally bumped the camera, so let me readjust that. All right, now nothing divides and becomes 1, so there's no holes. Okay, next step is we want to find the vertical asymptote by setting the denominator equal to 0. So the denominator here is x plus 2 and x minus 2. So that's x plus 2 equals 0 and x minus 2 equals 0. So x equals -2 and x equals 2. Okay, just like in example 1, I'm going to graph the vertical asymptotes in yellow. So x equals -2. And x equals 2. Okay, next step is we're going to find the horizontal asymptote or slant asymptote. So we're going to divide x squared into 2x squared minus 2. Now, the question you ask yourself is, what do you multiply x squared to give you 2x squared? The answer to that is 2. The quotient is done. There's no x, so it's a horizontal asymptote at y equals 2. So that means you have a horizontal line at 2. Dashed line, I should say. Okay, next step is to find the x-intercept by setting the numerator equal to 0. So here the 2, that just divides out, so you don't have to worry about that. But So here we said x plus 1 equal to 0, and x minus 1 equal to 0. So x equals -1, x equals 1. So your zeros are -1, 0, and 1, 0, which would graph in pencil. So -1, 0, and 1, 0. All right, now the next step is we're going to get the critical points. Now, here we need to find out if the curve is above the blue dashed line or below. So we're going to test the point -3, okay? So when x is -3, we need to find out the f of x value and find out if it's above the blue dashed line or below. Now it will tell us what the curve is. So we're going to plug -3 into the function. So that's f of -3 equals 2 times -3 squared minus 2 divided by -3 squared minus 4, and that equals 3.2. So our point is -3, 1, 2, 3.2 is about right there. Now, why that's critical is because that tells us now the curve is right there. Okay. Now, I'm going to have to steal some space from example 4 because we have several points we need to look at. And space is limited, so I'm going to have to add an extra line here. Okay. Because now, here we have 2 points here, but the problem is we don't know if the curve is the points here or here. So let's do f of 0. So then that's 2 times 0 squared minus 2 divided by 0 squared minus 4, which equals 0.5. So that tells us our point is 0.5, which tells us that our curve is here. Okay, now our last critical point is we need to find out what's happening here, so we're going to use x equals 3. So f of 3 equals 2 times 3 squared minus 2 divided by 3 squared minus 4, and it equals 3.2. So at 3, 1, 2, 3.2 is about right there, so our curve is right here. All right, so if you would go ahead and finish up example 2. All right, now let's take a look at example 3. All right, so first step is factor the expression. Well, in this case, the only thing you factor is x times x, and it's kind of pointless, so we're going to leave that there. Now, nothing divides and becomes 1, so there's no holes. Okay, next step is find the vertical asymptote by setting the denominator equal to 0. So we set x squared equal to 0. So x equals 0. So your vertical asymptote is 0. Okay, now the next step is to find the horizontal asymptote using long division. Now, I made a slight mistake, which I corrected on example 1, which let's not make that mistake in this one. Now I need to put a 0 squared plus 1x minus 1. Now, the reason why you need 0x squared is because you need to find out what makes x squared. Well, so what do you multiply x squared to give you 0x squared? The answer to that is 0. The quotient is done. So you have a horizontal asymptote at y equals 0. All right, so okay. Now the next step is we're going to find the x-intercepts by setting the numerator equal to 0. So x minus 1 equal to 0. So x equals 1, so you have an x-intercept at 1, 0. Now this is a rare occasion in that normally points can't lie on the asymptote, but in this case it did. All right, so now we need to do critical points. Now we need to point to the left of x equals 0 and to the right of y equals 0. So here I'm going to use x equals -1 as the first one. So we do f of -1 equals -1 minus 1 divided by -1 squared, which equals -2. So the point -1, -2 is right here, which is critical because now it tells us the curve is right here. Now we already have a point here, but we need to know one more to find out if it's going up or it's going down. So let's use x equals 2. So f of 2 equals 2 minus 1 divided by 2 squared, which equals 1/4. So our point 2, 1/4 is about right there, which tells us that our curve is going up here. Again, this problem is rare in that normally the curve never crosses the asymptote, but in this case it does. All right, so if you would, finish up example 3. All right, let's take a look at example 4. All right, so normally I factor to the right, but because I do space here, I'm going to factor to the left. So 2 parentheses. And then here, we can actually factor out an x from the denominator, so that's x minus 1 and if you have whiteout you might do that. I'm going to so I have space because I want you to see this problem correctly. I'm going to steal some space here so I can factor it better, so that way I can have 2 parentheses here and then all right. So now x and x. Now we need to find all the combinations to make 2 combined to be -3. So in order to get a positive number multiplied and a negative number in the middle, both numbers have to be negative. So -1 times -2 is +2. -1 minus 2 is -3. This combination works, so our factors are -1 and -2. So I have x minus 1 here and x minus 2 here. Notice that I put the x minus 1 here because you see that if you divide x minus 1 divided by x minus 1, this becomes 1. Thus, we have a hole, and we need to set x minus 1 equal to 0. Okay, so then x equals 1. Now, a hole is a point, so we need to plug 1 back into the equation, but we're not going to plug it into here because this divided out. We're going to plug it into here. So f of 1 equals 1 minus 2 divided by 1, which equals negative 1. So our hole is the point 1, negative 1. Now, when you have a hole, it's an open circle. So 1, negative 1, there's an open circle. There's a hole. Okay? Now, next step is we're going to find the vertical asymptotes by setting the denominator equal to 0. So we're going to set x equal to 0 and x minus 1 equal to 0. Well, but wait a second. X minus 1 divided out, so that's not in the denominator anymore. So we only set x equals 0. So we have a vertical asymptote at x equals 0. Okay, now the next step is we're going to find the horizontal asymptote or the slant asymptote by using long division. So we have x squared minus x divided by x squared minus 3x plus 2. Now you ask yourself, well, what do you multiply to give you x squared? Well, the answer to that is 1. The quotient is completed. So you have a slant asymptote at, or not, well, horizontal asymptote, because there's no x, at y equals 1. Okay. Now we need to find the x-intercepts or zeros by setting the numerator equal to 0. Now you only set, because remember this is divided to become 1, the x minus 2 equal to 0. So x equals 2. So your 0 x-intercept is 2, 0. Now, that gives us one critical point because that tells us that our curve points lie below this asymptote, so our curve lies below that asymptote. Now we need to find out if the curve is above or below by picking a point. We use positive 2, 0 work. Let's just go and use negative 2. So then that's f of negative 2 equals, we're going to plug negative 2 into here, so that's negative 2 minus 2 divided by negative 2, which equals negative 4 divided by negative 2 is a positive 2. So negative 2, positive 2 points there. It tells us our curve is here. Now, I normally don't do this and go back to a problem, but example 1's long division has kind of been bothering me, so I want to redo that for those of you that bother. Okay. Okay. So let me do this correctly without mistake. Okay. So you ask yourself, what do you multiply x by to give you x squared? The answer to that is 1x. Okay. Now, as soon as you get an x, you know it's a slant asymptote. Now we multiply 1x times x is x squared. Okay. Now you subtract. This goes away. Now you bring down the 1x. Okay, then you ask yourself, well, what do you multiply x by to give you 1x? The answer to that is plus 1. Hopefully that explains to you a little bit better, and it takes away some of the frustrations of when I made the mistake there. Okay? All right, so with that, mistakes have been corrected and re-explained. Go ahead and finish up example 4 and start working on your assignment, and have a wonderful Wildcat